What is the origin of our universe? Researchers at the Large Hadron Collider, the world's largest particle accelerator, are trying to understand why anything in our universe, every bit of matter, exists at all. The LHC smashes protons together as they travel a 17-mile loop at close to the speed of light, producing more than 500 terabytes of data every second. Researchers then need to filter that raw data in real time to isolate the most interesting events. Scientists at Fermi National Accelerator Laboratory, CERN, MIT, the University of Washington, and other collaborators, working together with Microsoft, have prototyped their data analysis problem on Azure Machine Learning and demonstrated significant gains in speed. With the ability to accelerate the building and training of sophisticated models, Azure Machine Learning has the scope to handle the LHC's zettabyte-sized data challenge. Soon, it may help researchers identify the handful of collisions among millions that might give insight into the moments after the Big Bang.
Thank you. Hello and welcome. My name is Eric Boyd and I lead the Azure AI team here at Microsoft. And we want to spend some time today really diving into the way that you can use Azure AI to really help drive the new innovations and new businesses and new solutions that AI is empowering for businesses everywhere. We've seen AI really transforming each and every industry really around the world and in every company that we work with. And our vision here is we want to help empower our customers to use AI to create these new solutions, these new business areas, these new models that they're really pushing for. And we're seeing tremendous momentum really coming in the AI space. AI is no longer this secret sauce up in the laboratory. It's now real. It's now touching businesses. And we're seeing that with businesses everywhere. We have over 20,000 paying customers in Azure just last month, representing 85% of the Fortune 100 businesses. AI is everywhere and it's really expanding into each and every corner of the businesses that are out there. And so when we think about how do we help bring this to all of the customers that we work with, for us, it always starts with breakthrough research. See, we've been working with research labs really from around the world that have collaborated and worked together to create some of the most groundbreaking research and achieving human parity in all of the AI-focused fields of vision, of language, of speech, all different areas that are really accelerating and creating new opportunities for businesses everywhere. And then we take that research that we've worked with our teams to develop, and then we bring it into our Microsoft products. We're really privileged to have a wide span of products that we can really show these against and prove them out at scale and really showcase that these things really work for enterprises. And so you can see with something like Bing, where we have 435 advertising recommendations per day, where we're showing advertisers how they can better connect with their customers, how they can have better text in their ads, and how they can sort of time that better. We're using PowerPoint to save people from boring PowerPoint slides one slide at a time, with over 1 billion designer slides recommended powered by Azure AI. Xbox is delivering personalized experience to its users with over 80 million recommendations of new games to play, new people to connect with, again, powered by AI across all of these fundamental systems. We then take this research and then we bring it to our customers through Azure. And I want to talk to you today about the 3 primary ways that we work with our customers to deploy AI solutions at scale. There's machine learning, the way where you can use this powerful platform to create your own custom models. There's apps and agents where you can use a suite of cognitive services and the bot framework to create bots on your technology. And knowledge mining, where you can really unlock the power of the documents that you have locked up in your enterprise and use those to make those more available. So let me go through each of those in turn. We'll start with machine learning. The Azure Machine Learning system has really grown a ton. We're now driving over 1 million experiments every month. And those 1 million experiments, how are we sort of achieving that? One of the key things we've focused on is making Azure Machine Learning easy for everyone of all skill levels. So whether you want a no-code approach using our designer powered by automated machine learning to help you create a model, or if you want a code-first focused experience using a Jupyter notebook to really help you create your model, you can do all of those things using Azure Machine Learning. We've also really simplified the operational side of things using MLOps. MLOps, which is the sort of DevOps equivalent for machine learning, really makes it easy to create automated pipelines, to automate the workflow, to get the monitoring and feedback back, to get control over all the different places where your models are going, and really make that management much, much simpler. We've also focused on making it open and interoperable. And so what that means for us is whether it's your favorite open source framework or your favorite developer tool, those are all integrated directly into Azure Machine Learning. So frameworks like PyTorch, like TensorFlow, like scikit-learn, like the Onyx accelerated runtime, those are all directly integrated into Azure Machine Learning. The languages that you might want to use from Python to now we have R support added in, also directly integrated into Azure Machine Learning. To the tools that you want to use, if you want to use a Jupyter notebook, if you want to use leading IDEs, things like VS Code, also easily integrated with Azure Machine Learning. But the fourth thing that we've really done to drive this forward is focus on being the trusted and secure platform for our customers. We hear from customers every day that they want to make sure that the AI that they're deploying really is trusted, that their data is being managed securely, and we want to help them. We're introducing new tools to make it easy to look at the bias in your tools using standard responsible AI frameworks and toolkits, and really helping with the explainability of what is this model doing and why did it predict the things that it predicted. Clicking a level deeper into machine learning ops, this is something we've heard a ton from our customers that they're struggling with and really finding value in the solutions that we're creating. See, when you think about machine learning, there are these two key personas of the data scientist and the IT professional. The IT professional is the person who needs to manage all of the different workspaces that they want to create, the storage, the queues, the compute availability, and they want to help deploy this to production and manage the automation of these things and really make all of this, the production site needs to just go. And the data scientists, they want to just focus on creating these fantastic models, coming up with the innovation, what are the new features, and retraining and iterating on that. And allowing each of them to sort of focus on their specialized areas, allowing the automation, the pipeline creation to sort of pull all this through, and then the monitoring to understand how is this performing and is it performing the way that I expected to. Azure Machine Learning makes all of that very simple and integrated to bring those two personalities together and make that really simple. So today I want to talk about some of the new capabilities that we have in Azure Machine Learning. Today we're announcing the Enterprise Edition of Azure Machine Learning. And what the Enterprise Edition does is it really brings together for a data science professional all of the things that they might want to be able to do together into a single place. So everything from being able to do a low-code designer to go and use drag and drop interfaces to create your models, to using automated machine learning to get automatic feature selection and hyperparameter tuning and really accelerate the work that you're doing there and really dramatically simplify that, this nice unified experience all in a single place. We're also wanted to talk about Onyx, the runtime. This is an open source project that we've collaborated with in the industry to really accelerate the performance of inferencing of models. And we see dramatic improvements when we use this internally. We see basically 2x performance on the average model that we use internally from this at Microsoft. And so we've now like to announce that the Runtime 1.0 has been released, adding more accelerants for different types of hardware and more custom-tuned kernels to really make these things work quickly. And lastly, I mentioned R support. This is something we've heard a lot from our customers that they wanted to see R support, and we've now integrated that directly into our products. But more than talking about it, it's much better to show it. So what I'd like to do now is invite Stephanie and Nishant to come up and show us some of the new capabilities that we have in Azure Machine Learning. Stephanie and Nishant?
Thank you, Eric. We've seen enterprises struggle with three main challenges when deploying machine learning solutions: lack of governance and control, too few people understand machine learning, and operationalizing your machine learning models. Today, we're going to show you how Azure Machine Learning solves each of these. So first, I'm going to play the role of the IT admin, and I'm going to set up the appropriate governance, controls, and spending limits. Here on the Azure Portal homepage, an IT admin can create environments for data science teams, define roles, and set quotas. I've already created a machine learning workspace. A workspace is an environment where teams can collaborate on their machine learning projects. Now, to secure my environment, I'm going to click on Workspace. I'm going to navigate to Access Control, and I'm going to define the roles for my teams and grant permissions for each of those roles. Now, Nishant is on one of the teams, and I'm going to grant him owner access to the workspace so he can create the Azure Machine Learning assets that he needs. Now, to control costs, I navigate to Usage and Quotas, and I can prioritize the compute resources that I need by setting the quotas at the workspace level. So now that my environment is all set up, Nishant he can go to ml.azure.com and start creating machine learning models.
Thanks. As Stephanie mentioned, I can directly go to ml.azure.com and get to the new Azure Machine Learning Studio. Now, this studio is actually the enterprise machine learning portal for everything that we want to do over here. It has an experience for code first with notebooks, with no code, with automated ML, and a visual drag and drop designer as well over here. Now, what's really, really interesting is I get to see all the assets that my team produces as well. Datasets, experiments, pipelines, models, all of this in a single pane of glass. Now, as a data scientist, if I were to go ahead and create a customer churn model, there are a lot of repetitive tasks that I have to do. Feature selection, algorithm selections, hyperparameter tuning, etc. Let's see how automated ML can help me actually automate a lot of that process. I'm going to go ahead and start a new AutoML run. And all it asks me is three things: a data set, a configuration of the run, and any settings I might want to customize over here. Now, I could bring in a data set from anywhere, from any of the web sources, or even from my local environment. I already have a data set loaded, so I'm just going to go ahead and select that one for now. As I go to the next step over here, it takes me to input some details about the machine learning experiment as well. I'm going to go ahead and do that. I'm going to tag this experiment to an existing experiment that I have. For the target column, of course, I want to look at the data a little bit, so I can view the data set real quick. And I see this is general demographics data about customers' behavior, but it also has a churn column, which has true false. This looks like a good column to predict. I'm going to use churn as the column here. And then to select a training compute, I already have one set up for Stephanie, so I can reuse that one really quickly. As I go to the next step over here, it asks me to select what kind of processing do I want to do, whether it's a classification. In our case, of course, it's a true-false. So it's a classification. I'm going to enable deep learning also over here. But mind you, there's also regression and time series forecasting if you wanted to do. Now, as soon as I click on Finish over here, the automated machine learning engine now goes and gets to work. It sifts through all the features, the algorithms, and tunes hyperparameters to come up with a bunch of models and even a recommended model for me. Now, this might take a few minutes for this one to run, so I'm going to go ahead and select one that I executed a while back. Now, here's a run. Here's a recommended model that automated machine learning came back with. I can even go ahead and look at other models that it deduced and see what the details for those are. I can drill down into them. I can see visualizations for a lot of parameters like precision curves, ROC curves, etc. And even better, I can see explanation of my model. Now, this is really important. It actually tells me why a model is the way it is. It tells me which features have maximum impact. In this case, if a customer has a contract from a month-on-month basis, they have a very high chance of impacting the model rather than any other parameters over there. Now, that's really important. I went from raw data to an explainable model in a span of minutes, and I can even deploy them very easily with the click of a button.
Wow, that is easy. So what about people with more machine learning experience?
Absolutely. As I said, Azure Machine Learning is there for all skill levels. I could go ahead and use a notebook experience to get started with a code-first environment. But me, being me, I'm going to start with the visual drag and drop designer and design a visual experiment over here. Now, for this one, I'm going to start with something that one of my colleagues had already started putting together. So I'm going to click on this one.
So you can just pick up where she left off?
Absolutely. Azure Machine Learning is built for collaboration at the core. As you can clearly see over here, we've imported data, and we've also tried out a couple of algorithms over here. I could easily drag and drop more algorithms if I wanted to test them, and it's as simple as dragging the algorithm into the canvas over here. I could even go ahead and write Python and R scripts if I so wanted to. What's the interesting part over here is that although we are dragging these modules, I have the power to tweak and customize them to my heart's content. And when I'm ready with my model, I can just go ahead and run the experiment or publish it as it desires. Now, Stephanie, now that we have this model in place, please help us understand how you can operationalize this using CI/CD pipelines.
Sure. So first, regardless of how your models were created, they're all located in one place, along with all of your other Azure machine learning assets. Now, earlier I mentioned the challenge of operationalizing your machine learning models. So now I'm going to play the role of an ML engineer, and I'm going to take those models and I'm going to put them into my production Azure DevOps environment. Now, you'll notice that the models are first-class citizens of Azure DevOps, and they trigger release pipelines just like any other triggers. They then move into the QA stage to perform a series of tests. You can set your pre- and post-deployment conditions, as well as your conditions of approvers. Once all the quality gates are passed, the approver signs off, it moves into my production environment. Once the deployment is complete, it creates an endpoint, and then I see that show up right inside my Studio UI. So today, we showed you how Azure Machine Learning is an enterprise-ready solution that solves for lack of governance, caters to different levels of machine learning expertise, and has robust MLOps capabilities. If you'd like to get started, you can click on View All Tutorials. Thank you. Back to you, Eric.
Thank you. I think that's very exciting to see all of that come together in the workspace. I think the power that we can really achieve there is really going to be great. Really looking forward to seeing that further. So one of the things we've heard from a lot of our customers is that they'd like help understanding what are the places where they can really deploy ML. So what we've done is we've compiled a set of common scenarios, and I'm not going to go through each of these, but there are sessions all throughout the week diving deeper into each of these different scenarios you might want to learn more about. But I want to talk about a couple of them in a little bit more depth. I'll start with predictive maintenance. So Schneider Electric is a company that we've worked with in the energy and gas oil and energy and gas field, and they have devices on their wells which, when they fail, they can end up taking the entire operation down and cost them lots of money. So what they do is they want to prevent this, and so what they start with is just gathering some data. So they put a device at the well site that now can sort of, through IoT Hub, stream the data back into a data lake or into a stream processing environment. Now the next thing that we want to do is add AI into it. So what we do is we start by using Azure Machine Learning to take the data from the data lake and to build a model, training it to try and predict when these various things are going to fail on the well site. Once we've built and trained our model, now we need to deploy it. So we use Azure Machine Learning to package it and deploy it back through the IoT Hub and back to the device at the well site. So now I have a model running at the well site that can give me telemetry and information on when I expect this device to fail. And now I sort of gather all of that back and start to monitor it. And the thing I'm really looking for here is to see, is the performance of this model matching the data that I trained it on, or do I need to retrain and sort of relearn from there? And this step of being able to sort of build the model, gather the data, retrain, package, deploy, and then monitor it, this is a pattern we're going to see repeated a number of times. And when working with companies like Schneider Electric, they've seen lots of improvements both in their reliability as well as in the safety of the system that they're using. Another place that we see a common use pattern is in inventory management. And so here, if you think of a retail store that now has their point of sale data fed into the data lake, they then run that data through Azure Synapse and into Power BI where they can do some analytics on it. And then they have an inventory management system where they can try and guess how much of each item they're going to need to keep in stock. Again, here we want to just add AI into this model to really sort of leverage the power of AI to predict better when I'm going to run out of inventory. So I gather the data from the data lake, I build and train the model, and I package and deploy it just like I did the last time. And this time, maybe I have lots of stores, and so I actually want to batch inference this data across all the different stores that I have to really get predictions unique to each individual store, and then feed that back into Azure Synapse so that shows up on the ordering form for them. And again, I monitor this and look to iterate through this process. These are the types of things that we're seeing customers do all over the place, and there are more scenarios that we can talk about. But to dig a little bit deeper into this, I'd like to invite Anita Klopfenstein from Little Caesars. Little Caesars, one of my favorite pizza brands that I've been eating ever since I was probably in middle school, and to talk a little bit of some of the things that they're doing with this. So Anita, great to see you.
Good to see you.
So tell us, what's your role at Little Caesars?
Well, at Little Caesars, I am the Chief Information Officer, where I have the privilege of working with some great IT professionals that basically support thousands of our stores worldwide with our POS system, our kitchen display, online ordering, and back of house. We also support Illich Holdings' 10 companies, which includes our award-winning Little Caesars Arena, Red Wings hockey team, and Tigers baseball.
Ah, very nice. And so what was the business problem you were looking to solve here?
Well, with our hot and ready model, our goal is that during the hot and ready hours, you can walk in, get a pizza, and walk out in less than 3 minutes. When that works, it's great, but if the pizzas aren't ready, we saw low customer satisfaction, as well as in some cases, they could actually leave the store. Adversely, if we make too many pizzas, we increase our waste and the cost to our franchisees. So we were looking to improve our demand forecast model.
That makes a lot of sense. I certainly, when I walk in, I want that pizza ready for me, but you don't want to drive up the cost. How did you manage that? What did you do?
So what we did was we worked with Microsoft and we leveraged the Azure Machine Learning platform. With the AML, we used two main features. For our feature engineering, we used Azure Databricks to load all of our historic point of sale data efficiently. And then we enriched it with weather, local events, utilizing Azure Machine Learning's SDK open data set. So then once we loaded all of the data, the teams created thousands of models. And they did this with Azure's automated machine learning. From there, they actually created a model for every store and every single hot and ready product for that store. And they ran that through 11 forecasting algorithms utilizing hyperparameter tuning.
Wow, so one for each store and for each product in the store. That's really amazing. And if you don't mind sharing, what was the impact of that?
Oh, we had a great impact. What we saw was the likelihood of you being able to walk in, have a hot and ready pizza ready, and walk out of the store improved by 20%, which means that was great for customer satisfactions, increased sales, and ultimately strengthened our Little Caesars brand.
Well, that's fantastic. Thank you so much for sharing. I appreciate you joining us.
Thank you.
So the next area I want to talk some more about is the apps and agents space. And so when we talk about apps and agents, we typically are talking about our suite of cognitive services and the Azure Bot Service, where you can create your own bots. And we've seen tremendous growth in both of these. Over 5 billion transactions a month in cognitive services and over 1 billion messages a month on the bot service. And when we talk about our suite of cognitive services, we've really focused them on these different areas, these categories of decision, language, speech, vision, and web search. And we've had so much new things coming in them. There's a lot of new information to announce here, and I'm just going to quickly race through some of the highlights in it. Within the decision space, we announced earlier this year the Personalizer service. This is a service that's based on reinforcement learning to figure out what's the best content to match with each individual. And this new technique won the Most Innovative Product Award at a Strata conference earlier this year. And we're happy to announce that this is now generally available. Moving to the language side, there's been tremendous really progress and innovation in natural language processing over the last 6 months to a year. And so what we've done is we've brought all of the innovations that have come from the industry into our product to dramatically improve the sentiment analysis and improve the results that you're seeing there. In addition, we sort of brought those capabilities to help with text analytics and extracting different entities. There are now over 100 entity types that you can extract and over 80 types of personally identifiable information that we can extract from text and understand as an entity. Within the vision space, we introduced earlier this year Form Recognizer, where you could take a number of forms and upload them to the site and get structured data in JSON format, key value pairs out of it. What we've added now is the ability to do this feedback loop where if the performance of the form recognizer isn't meeting the bar that you have, you can, with a simple labeling tool that we've added, label the different data to improve the accuracy that the form recognizer is seeing and get a much higher quality output as a result of that. Within the speech space, we're introducing custom speech with Office 365 data. So the idea here is that we're training for each of you who are using Office 365, we can build a custom model for your organization built on top of the public documents and public groups that your organization, everyone in your organization has access to. So then we can understand the terms that your organization uses. For example, in my business, we talk about Kubernetes, and understanding what that is and how to spell it requires access to that sort of data. Another thing we've added is custom neural voice capability. This is something that was talked about earlier and is powering the feature of reading your mail in Outlook. The other things that you can do with this custom neural voice capability is that you can create custom voice fonts, where now you can enable a service like customer service being able to answer on a company's brand or on their mascot in that exact voice. Now, because we have such a commitment to deploying this technology responsibly, we're going to be releasing this in private preview, in gated preview with selected partners. And we'll work closely with those customers and with public interest groups and with the voice acting industry and with ethics researchers from around the world, really to help develop the principles for where and how this technology should be used responsibly. But one of the most powerful cases that we've seen of this technology is with the Beijing Hongdiandian Vision Service Center. And so this center is really focused on providing tools, audiobooks, and educational resources to help people with low vision. And so Lena is the first blind certified broadcaster in China. And she works with the Hongdiandian Center. And so let's hear her story.
我是董丽娜，10岁那年，我完全失明了。现在，我是一名播音员，也是一名语言艺术培训师，在红丹丹帮助更多的视障朋友学习朗诵和播音主持。在给予他们知识的同时，我也特别希望能够给他们带来更多的机会，让他们可以去选择不一样的人生。在多年的学习和教学经历之中，我深深地感受到，适合视障人士学习的书籍太少了。幸运的是，通过微软公司的语音技术，我用自己的录音样本定制了一个人工智能的声音。这个声音很好地复现了我本人的音色。我们也在微软的帮助下，设置了这个声音的使用方法。现在我们可以通过这个声音来朗读适合视障人士聆听的各种书籍。通过红丹丹的心目图书馆，这些有声书可以发放到全国105所盲校，让更多的视障朋友可以借助他们来学习。我希望用我的人工智能声音帮助到更多的盲人朋友。我想跟所有的视障人士说一句：要相信你自己的潜能永远比你想象中更强大。
So a really powerful story. Thank you. And I don't know how many of you caught at the intro, but that entire speech was generated using custom voice. And so while my Mandarin isn't up to par, you can hear sort of how natural and fluent it sounds as opposed to the robotic voices you're used to hearing. And that's really enabled them to translate many more audiobooks and to provide more of them with different voices so that people can choose the voice that sort of best matches, is most pleasing to them, and they can understand the most clearly. And so really excited about the work with that. Moving to the bot side of apps and agents, there are a number of things that we were looking to announce. The Azure Bot Platform is an open source platform with the most contributions of any bot platform that's out there. And one of the things we're introducing today is the Composer feature, available in preview on GitHub, where now you can use a low-code experience to create your own bots using this environment that it creates for you. Additionally, you can now easily deploy and manage these bots across multiple channels, everything from Teams to Facebook to lots of places you might need to manage them. And then all of this comes together, powering the Power Virtual Agents that was announced earlier today as well. Power Virtual Agents is a no-code version a SaaS service that you can go and create your bots. So regardless of which level you want, of no-code, low-code to code first, we've got the right environment for you to make it really easy to control and customize the bots that you're building. Now again, when we think about the scenarios that we've heard from our customers that they're using, I really want to walk through a couple in detail, but again, there are going to be sessions all throughout the week covering each and every one of these. So robotic process automation is an area that has really grown tremendously over the last year. And one of the things that we hear a lot of are a customer that has a bunch of client reports that they're then loading in, and they want to call an Azure function to really call Form Recognizer. And they're going to use Form Recognizer's feedback loop capability to really make sure that it's doing an accurate job of understanding everything that's in this client report, so then they can put it in the data store and then have dashboard reporting on it. And so this is a very common RPA type scenario of taking a workflow that typically a person has to be involved in and just automating the entire process of it using the cognitive services and the Form Recognizer to really make that simple. Another area that we've heard from a lot of customers is around intelligent customer support. And this is a solution that we use internally at Microsoft as well with our customer support systems. Here again, a customer calls in, and you take those calls and you run speech to text on them to get a text form of that call. And then you can run text analytics on it. You can get things like sentiment analysis, you can get understanding of the different entities, the key phrases, the named entities that they're talking about, and then feed that into a real-time processing engine where you can then take intervention on different things based on the feedback that you're hearing. You can run batch processing to understand what are the areas that the customers are having sort of the most negative sentiment in your product and what they're struggling with, and to get real insights just from the calls that your customer call agents are making. And so Allstate is a company that's been working in this space, and so I want to share a video from Allstate on some of the things that they've been doing.
The insurance industry is a legacy industry. It's been around for hundreds and hundreds of years, essentially unchanged for that period of time.
Insurance is one of those industries where we felt a little protected, but we know that disruption is coming, and Allstate's really tackled that head on.
At the beginning of our digital transformation journey, we realized that when a customer reports their accident initially, they were providing a whole bunch of rich detail that we're not able to capture effectively.
When a customer calls us, it's a pretty traumatic experience for them. So we want to make sure that they can move through that feeling of fear and to reduce all of their effort and the friction that they need to go through.
We set out to solve how do we capture that initial customer interaction to make it a less effortful experience for our customer.
So we've leveraged technology to make things really quick and easy for them.
We decided we were going to capture all of the voice calls that we had with our customers. As part of capturing that, we were going to transcribe the calls using artificial intelligence techniques.
With our transcription work, when a customer reports their accident initially, we're able to take all of that rich detail and figure out, without involving them, how to process their claim. They only have to explain what happened once. Custom speech allows us to create custom models that'll specialize it for our insurance-specific vocabulary.
The ability to customize was a really powerful thing for us. It was one of the things that Microsoft offered us that a lot of other providers didn't. This work is helping us evolve in that journey to move to a digital world and to meet the customers where they expect to be met.
Being at the forefront of innovation really puts us in a great position to take care of the consumer, be very empathetic with the consumer, and do so in a manner that absolutely exceeds all of their expectations.
So with that, I'd like to invite Kamal Natarajan from Allstate to come and talk to us a little bit more about the work that they've done. Thank you, Kamal.
Thanks, Eric.
So tell me about yourself. What's your role at Allstate?
So my name is Kamal Natarajan. I'm the Chief Information Officer for Allstate Claims. Super excited to be here to talk about some of the cool tech and innovation that Allstate's been working on, as you could see in the video, to deliver on our promise of enabling the best claims experience on the planet.
Oh, that's great. And so I think we got some sense of it, but why don't you tell me a little more? What's the problem that you guys were working to solve?
We are on a journey, Eric, and we're trying to eliminate the many friction points that exist today in the claims experience, a typical claims experience, and this applies to the industry, not just Allstate. At Allstate, we are customer obsessed, but we also believe that the customer experience cannot be greater than the employee experience. So the team of talented people you saw in the video, some of them are here today, they set sail to solve with one objective in mind, which is let's eliminate the need for customers to have to repeat themselves when explaining their claims experience or discussing their claim with the Allstate employee. And they did that by using the original or the first, the voice transaction or the voice recording, and unleashing a cool stack of technology powered by things like voice transcriptions using your product, the Azure
Speech recognition.
Speech recognition, thank you.
Yeah.
Artificial intelligence and machine learning to essentially contextualize and transcribe the voice recording and present that information downstream to anyone that needed to consume it to make a good decision on behalf of the customer.
And that sounds great. I mean, I've certainly been frustrated before when you call and you have to repeat with each agent exactly the story that happened. And so you're using the speech to transcribe it so that each agent then can sort of quickly sort of get the context on the things that they've done before. Yep. That sounds really quite powerful. I mean, tell me something about the impact that you're seeing with that.
Well, we are expecting to see a ton of efficiencies because we know it's saving a ton of time. Think about a typical claim experience like you just said. It's a long-ended transaction, a lot of touch points. Unfortunately, many times a customer has to call or inquire. What we've done is we've essentially enabled the need for customers not to have to call us, and for folks that need to use that transcription to get it on demand. But most importantly, it's enabled our customers to drive that empathy in the conversation and essentially deliver a humanized claims experience for our customers.
Well, it sounds really great. Well, thank you for sharing that with me, and I really appreciate you coming and talking to us about it. Thanks a lot. So the last area I want to talk about today is knowledge mining. And knowledge mining is the process of taking all the data and documents a company already has and extracting information from it. And we typically showcase that through search and products like Azure Search. But the application search has really evolved. Search started really in this keyword model where you had to learn the language of the search engine and figure out exactly which words to get the results back. And really then it's evolved into this contextual search where now I can say more natural things like a famous tower in Paris and expect that to still come back with information about the Eiffel Tower and the thing that I'm really looking for. The next phase that we really see is this cognitive search. Here, this is the place where you're going to express the query naturally and expect it to find things, not just text in documents, but also images related to it, also handwriting recognition, using all of the suite of cognitive services to find all of the information about the things that you're working through. And so as I mentioned, we generally showcase this through Azure Search. Azure Search is a fully managed system. You know, search is really complicated to run, and we simplify that for you. And you can leverage the full suite of cognitive services built in AI, and you can customize it by adding your own skills. And since we really felt like the cognitive part was the important part of it, we've changed the name to call it Azure Cognitive Search. And this is being used at tremendous scale. We process over 6 billion documents every day. And the way this works is the data is taken in and ingested, and those suite of cognitive services run across the documents to extract everything from the language, doing the text recognition on it, face detection, anything to really build this data set that we can then use to run search on top of. This data set, if this were on a bunch of documents about the Eiffel Tower, would have the history, the design, and you can start asking for things like, give me the background of the Eiffel Tower, and expect to see real relevant results. And we have a ton of use cases in this space as well that we've heard from our customers. And so again, more sessions that you can go and find out lots of information about all of these. But a couple that I want to pick on is auditing and compliance. There are companies that we work with where they have lots of data. Maybe it's a 30,000 page contract. And what they're going to do is they're going to extract all the information out of it using the suite of cognitive skills, the language detection, the named entities, automatic translation if necessary. And then they're going to build their own custom skills to detect, key clauses, say things about GDPR, things that they want to identify there, scoring the risk based on the text that they see. And then you can search directly against this contract to find all the GDPR clauses related to certain areas, locations, all the different facets that you can create from the document that you've got. And then you can explore it with the search. Another area is in digital asset management. And so this is, think of a place where you have lots of everything from images to old news articles and the like that you want to sort of be able to pull through and search and understand all of that information. So here again, running the suite of cognitive services against it, you can extract all the information about what the type of image is, the location that this image was taken. You can look for similar images based on that, feed it all into a search index, and then make it available to employees to really sort of surface all of this. And so a great case of showing how this comes together is with The Atlantic. The Atlantic is over 160 years old and has news from just all throughout the last 160 years. And how can they make all that information available to all their editors? Let's watch.
The Atlantic started in November of 1857. It's one of the oldest continuously publishing magazines in the country. What The Atlantic has done over those years is really take a hard look at where we are in the world and have the tough conversations that need to be had.
So The Atlantic has, over the last 3 years, decided to place some pretty strong strategic bets on our future as a technology organization.
We have always talked about the value of our archives and the value of digitization.
Stuff that's 30, 40, 50, 100 years old, most publications don't have that information online. It is sequestered away.
And the real beauty and benefit of The Atlantic is that we can look at our own history over that time, see how we've covered that issue, and use that to inform how we think about it going forward.
To have an organization with the intellectual heft of Microsoft putting talent against developing cognitive services that can take a piece of text and identify those people, identify those places, identify those subjects is a really exciting prospect for us. You can construct far more sophisticated queries that can fish stories out of the sort of sea of news.
I think it's really important for us to lean into technological innovation and figure out what technology can do for us to make the pursuit of our journalistic ambitions and impacts all that much more successful. We're here to defend and test the American idea. We need to be able to look at what we've done in the past.
And to show us more about that, I'd like to invite Jamie on stage to come and show us a demo of what The Atlantic has done. Jamie?
Good afternoon, everyone. I'm Jamie Burgess, and I look after the Microsoft News Lab's AI and immersive practice. That's part of the Microsoft News charter with helping our 4,500 news partners digitally transform. Now, when a journalist writes an article, they often have to trawl their archives for historical context. And in the Atlantic's instance, that's 160 years worth of valuable insights that's just not available on the web. Coupled with that, the fast-paced moving news pace cycle, they need to be able to move fast, search normative content quickly and efficiently. So let's take a look at how The Atlantic is using Azure Cognitive Search to be able to optimize their digital workflow. So here you can see an article written by The Atlantic talking about the all-female spacewalk. But what about context? How do we think about how space and perception has changed over time? So let's flip to the tool we built to help media organizations look through their archives. If we can get the mouse, there we go. So we know that humans went to the moon about 60 years ago. But we know space was discussed long before that by astronomers like Galileo. So that seems like as good a place to start as any. So let's search for Galileo. And already you can see Azure Cognitive Search helping me find and navigate my archives with the facets that's extracted, the titles, the authors. But there's such a wealth of information here. So let me take a look at the insights and see what else can help. Now the entities have been grouped by organizations, people, and locations. But let's get a little more concise. Let's have a look at the relationships between these entities. And here you can see a great bubble chart, but I'm going to switch to the tree view, which shows some really interesting connections with people you'd expect, like scientist Isaac Newton, but one that I wasn't, William Shakespeare. So let's add him to the filter and take a peek at the results. And here we go. This interesting article written in 1904 took my interest. So let's have a little closer look. It claims on the left-hand side here that Shakespeare and Galileo were in fact born a few months apart. Interesting. But let me direct your attention to the right-hand side of the page where you can see the entities that are being extracted from the article and the archive itself. Coupled with Bing Web API, I can bring in the knowledge of the world to help not break my research workflow. And here you can see February 15th, 1564, and April 23rd, 1564. In fact, they were born a few months apart. An interesting factoid, but probably something I'm not going to add to this particular article, but I can add it to a portfolio and look at it for later. So let's cast the net a little wider. Thanks to cognitive search, I'm able to search for words within these archives and the distance between them. And again, a wealth of information coming back and a really easy way for me to preview and triage my search results. And it was this article that took my interest. The premise of going to space before we did in 1960, talking about some of the problems we might have to go through, nuclear radiation, acceleration, deceleration, extreme temperatures, weightlessness, a really interesting place to start my archives. But let's show the true power of knowledge mining and go back to some earlier content, the 1900s. This really interesting article, The Limits of the Stellar Universe. Now I'm going to scroll down to the right-hand side, and I'm going to help you by switching to the transcript that's extracted thanks to the OCR part of the AI ingestion pipeline. And you can see here, our only means of exploring the heavens is the combination of the eye and the photograph with the telescope and spectroscope. A really interesting premise in an article written in 1901, 2 years before the Wright brothers, in fact, recorded their first flight. Thinking about how the tools they have available to look up in space, and now we're in a world where a lucky few have the opportunity to look back down. So as you've seen today, we're showing you how Azure Cognitive Search has been used by the Atlantic to be able to look at their archives and use the connectivity between OCR, object vision, entity extraction, and Bing Web Search. It's a really great example of how AI is augmenting human ingenuity, creativity, and curiosity. Thank you.
Thank you, Jamie. And so I hope today I've been able to show you some of the ways that you can use Azure AI to really power new scenarios and new things for your business. As we say, we see the space just exploding with the opportunities of things that you can do to change and drive your business forward. And we've been really fortunate to work with a lot of great customers and are really excited about the momentum that we're seeing there and are really looking to move forward with that. As I mentioned throughout, there are a whole bunch of sessions. There are about 50 of them. These are just some highlighted ones that we thought, if you want to take a picture of this and sort of get some of the sessions that you can really follow up on, we think there's just so much power that you can tap into, and we're really excited to work with people and see what we can do together to really unlock the power of your businesses with AI. And so I want to thank everyone for coming, and really hope you guys have a really great Ignite, and hope that you can really use AI to really help power. Sorry, I went one click too far. To power the innovation of everything that you're trying to do. Thank you.
Pelosi Park is known as the birthplace of the rhino. In recent years, organized crime has infiltrated conservation, coming in and poaching rhino. Last year was 769 animals killed. Peace Box Foundation, we work together towards a common goal, combating wildlife crime and trafficking within Southern Africa.
If we don't have technology that can support us, I promise you the rhino will decline. I need to make sure that I'm fighting the rhino poaching. If you touch rhino, you touch me.
Rangers want to save rhino. They don't want to be technicians. And that's where we started looking at Azure in the cloud.
What we're looking for is to detect suspicious human activities on the images taken by motion-activated camera traps.
This photo is processed by a machine learning model and only sends down the relevant photos, which is humans and vehicles. Microsoft's such a massive contributor to open source.
We used Azure Machine Learning compute with GPUs. It's very scalable.
Microsoft, they are really contributing to a cause in South Africa that really makes a massive difference. These animals, they've been here for hundreds and hundreds of years. We want to keep it that way.